Okay, here's our video on sample space. So we use sample space in probability. The sample space is all the sets of possible outcomes. It's the set of all possible outcomes. That's the sample space. So let's use an example. Let's say we roll a die. In dice, one of them is a die. So what would you think the sample space would be? If we roll one die just once, what is the possible outcomes? That'll be the sample space. So if we're rolling just one die, and we know that there's 6 sides in a die, and there's 6 numbers, so this is the possible outcomes. We can either get a 1, a 2, a 3, a 4, a 5. That's the sample space. Now let's say we roll dice, 2 pairs of dice. And let's say, what outcome can we get? So we're just rolling the dice. What outcome can we get? Well, we can get a 1 and a 1, right? We can get a 1 and a 2. We can get a 1 and a 3, and so forth. Right, but there's more. There's more possibilities. So how many possibilities, how many outcomes do you think we can get if we roll a pair of dice? We can get 36 outcomes, and here they are. We did the 1s already. We have the 2s, the 3s, the 4s, the 5s, and the 6s. So there's 36 possible outcomes. Let's try another one. Let's say you're picking 2 different fruits, and here are the 3 fruits. We have apple, pear, and orange. So if you're picking 2, what are the possible outcomes you can have if you're just picking 2? What do you think? 6. Right? You can have an apple and an orange, or an apple and a pear, an orange and an apple, an orange and a pear and an apple, or a pear and an orange. Right? There's 6 possible outcomes. Right? And then you might say, well, isn't apple and orange and apple the same? Well, if you're picking them one at a time, you'll pick the apple first. Here we're saying you're picking the orange first. Okay, now let's look at some other example. Let's say you're traveling by car or bus to Center Valley. Right? And there's 3 roads you can choose to get there: maple, oak, and pine. We can make a tree diagram. So we can make a tree diagram of how we can get to Center Valley. Right? So here we are. Let's say here we are at A, and you can either go 3 routes. You can go to Maple Street to get there, Oak Street, or Pine Street. And with these streets, you can get, they're all connecting to Central Valley. So that's what a tree diagram would be. Now there's a term we should know. It's called the counting principle. And here's an example of how we can use the counting principle. So with the counting principle, let's say we're at a deli and they have meats and cheese and bread, and you want a sandwich. Well, let's say there was 3 choices for meats, there was 3 choices for cheese, and there was 3 choices for bread. With the counting principle, all you have to do is multiply all the choices. And you can see there's 27 possible combinations of sandwiches that you can have using the counting principle. So let's say we had 5 meats, and let's say we had 4 cheeses, and let's say we had 3 breads, right? Well, now the possibilities will increase to 60. That's how we do the counting principles. Let's now do a tree diagram with heads or tails. Let's say you toss a coin 3 times, heads or tails. What's the probability if you toss a coin 3 times that you will get heads, tails, and tails? So let's say we want to try to get heads, tails, and tails. First, let's make a tree diagram. Okay, let's look at all the possibilities here. So, move this out of the way. We can start with, let's say we roll the dice and we get heads. Roll it again, now we can get either heads or tails. We roll it again, we can either get heads or tails. Same here, we can either get heads or tails. And the same would be with tails. So here's the probabilities with heads. We roll the dice, we get heads. We roll it again, we can get this. We roll it again, we can get that. That's the first part of the tree diagram. Now with tails, move that up, it's the same thing. We have heads or tails. This is the first time we rolled, this is the second time we rolled, and that would be the third time we rolled. Right? And it's the same with if we had tails first. Right, so this is our tree diagram. So if you looked at our tree diagram here, you see that there's 8 outcomes here. 1, 2, 3, 4, 5, 6, 7, and 8. 8 on the bottom there. So if we wanted to get heads, tails, tails, we got heads here. So it'd be heads, heads, and then tails. This would be the route we're taking. So since we have 8 possibilities, let's go back here. We had 8 possibilities, and we only have one desired outcome. So the probability of getting heads, tails, tails would be 1/8. Again, here's the route. Heads, tails, tails. If we wanted to get heads, heads, tails, that would be that route. But it's head, tails, tails. And if we wanted to get heads, heads, tails, it would be the same probability. The probability would be 1/8. So that is the sample space and using probability with tree diagrams and the counting principle. On the next video, we'll talk about compound events. Great job.